This is the third part of the storefront problem. Before we figured out that for a sample of size 45, we determined that beta was about 0.2443. Suppose that it's necessary that the store determines that we want to make sure that beta is only 0.10 when mu is equal to 3318. How large of a sample is necessary to make this happen? To begin, we use the formula that we had for the computation of beta. And so our starting point will be the formula here. Recall that beta, the formula, is equal to phi of z of alpha plus mu naught minus mu prime over sigma over square root of n. And we want to make beta equal to 0.1. So to do this, we need to have that we have a bell curve, and the area to the left has to be equal to 0.1. And so we need to figure out the z value down here to make that work. Now we can do that with Microsoft Excel. And using Excel or a calculator, norm SN of 0.1 gives us a value of negative 1.28115. So negative 1.28155. Okay, so in other words, I want the area to the left to be equal to 0.1, so the left mark, the thing inside the parentheses here, so the thing that's inside the parentheses has to be equal to the number we just figured out, negative 1.28155. Okay, now in this problem, z alpha is known. That's the critical value from the null hypothesis. Both of these mu's are known. That's the mu from the null. Mu prime is the mu from the alternative. Sigma, well, sigma is not known, but its approximate value s is known, so that's known. The one unknown here is n, and so I have an equation to solve for n. So I just need to isolate the n and then get everything else on the other side. So to do that, first off, let's bring the z alpha to the other sides, and then I'm going to divide down this. So we have negative 1.28155 minus the z alpha that I had before, which was 1.645 approximately. 1.64, I believe it was 485. Okay, so that brings the z alpha to the divide over to the other side. Then I divide by mu 0 minus mu prime, so 3218 minus 3318. And then that's going to be equal to 1 over sigma, which is approximately 287, divided by the square root of n. So I have a somewhat complicated expression for n to solve, and skipping a few steps, we get that n is equal to about 70.5. So it looks like a sample of size 71 is necessary in order to, so I'll round up to 71. So a sample of size 71 is necessary to ensure a beta that's required. We also discussed in class that this can be written in a slightly compressed form, which appears here at the bottom left part of the screen. So z alpha plus z beta, you can see where that comes from. Here's the z alpha, there's the z beta, divided by mu sub 0 minus mu prime, we can see here at the bottom, times s, or sigma, which you get by multiplying 287 over here. And then what's left is 1 over square root of n, so then you square it to isolate the n all by itself. So there is our shortcut formula for determining the sample size that's required if a beta is specified.